Hello guys. So I'm trying to play RLCraft, which is a mod pack of Minecraft in this video. I try to divert my attention from all this other videos I do and made some gaming videos and we get a zombie right at the start. So this mod pack is quite different. Uh, it is real life Minecraft, or not kind of, but kind of real life Minecraft in a sense. There is a collection of different mods. So in this mod, you cannot get. Let me put down volume a little bit. Yeah. So in this mod, you cannot actually get uh, wood directly. You need to get gravel first, and after you get gravel, you need to make flint tools, and then only you can get wood. So gravel is something that you will find close to water. I guess. Yeah. No, just so it should be close. Yeah. So this is gravel. And yes, you to get any item that you drop, you need to either crouch or use right click to pick up the items because it is real life Minecraft, I guess. So while doing this video, I will be talking about few things which are important and are related to politics and such. I don't have a house. I need to find a house. Oh no. So yeah, today I was interested in talking about let's see, mm, quantum mechanics, right? So quantum mechanics is a newer field relatively in physics, but it is very strange in the sense that it seems to be in contradiction, at least slight, to all other fields of physics, especially theory of relativity. Quantum mechanics is very crucial in trying to understand the nature of the world because it solves a great mystery that classical physics could have. So, while the classical physics model seems more intuitive and reasonable, the problem with classical physics model is that it cannot explain how the world got created and what is the nature of the world in actuality. The whole idea was that you had a sort of a state of nothingness or something like that, and then there was a sudden burst of energy which created matter. With the relevant equation that you always know that E is equals to mc square, which suggests that matter and energy are interconvertible. Now, once we get that mass, right, what we do with that, right? So this mass had was under the influence of several forces like gravity and such, and thus it condensed to form elements of higher orders. And this is how the world was formed. The problem with this approach was that the idea that energy could convert to matter was problematic in the sense that if that was really true, then there was a question as to what when we think of matter. So let's get back a little. So when we think of matter, we try to think of something which has a shape, a size, a volume, a mass, but energy does not have any of these characteristics. So how can energy be a substitute for matter? Or how matter and energy could be interconvertible? If mass and volume were real, if space was real, if shape was real, then the shape would never lose. It could be broken down into other shapes. For example, we can break a cube of, let's say, iron into smaller cubes. of iron. We can melt it at least. So the shape is conserved in a sense that we can break down shapes and then we get pieces which if we combine again will give us the shape back the shape. But energy has no shape and no energy can be said to have mass. So what is the deal with that? How do we reconcile that issue? Well, quantum mechanics does this. So quantum mechanics argues that what we understand by these different properties of matter basically are actually kind of like variables. Because they are variables, they can be transformed from one state to the other state. Why would that be the case? Well, just think of a game like this, right? You have different registers. Let's say that there is a register which corresponds to the mass of an object, and there is a register which corresponds to volume of an object. You can, though those registers would have some value stored into it, but the value only gets any meaning based on what the register is being used for. So for example, in the register the value may be 100, which may reflect 100 kg if the register is a mass register. But if the register is being used as a volume register, it may reflect 100 liters. The values themselves are without units. It is the register which gives them their actual meaning. So from that we, oh no, I'm getting hypothermia. So from that we understand, yeah, yeah, anyway. So I need fire or something. So yeah, the values themselves are scalar, uh, or rather say without units. They are in sort of an absolute form. So what happens, right? If we try to just code the system in any other way, the same register can be used to represent another type of thing. Oh, is that a village thing? Kind of seems like. Let's go there. Yeah, it's a village. So where was I? Yeah. So that is the point, right? As such, if we conserve the values, we can say that something is conserved without actually needing to figure out how the mass and the volume get destroyed. The mass and the volume are not important there because they are decided, let's say, by the decoder, in which decoder which is analyzing the particular value. Oh, so the mass and the volume are just decided by the decoder. The value therein is something that perhaps needs to be conserved for the world to move from one state to another state. Quantum mechanics thus solves this problem. By quantum mechanics, we can just uh, conceive of a different type of system which kicks into an action when a object with a mass gets converted into energy. The reason why this uh, uh, analysis is also important because it explains a lot of other things. For example, it explains it explains why our world is the way it is. Oh, just got so it explains why our world is the way it is. Yeah, I'm affected by weakness and slowness. So let's get back a little. In our world, you notice there is a strange property that exists, which is the randomized motion of electrons and any quantum particles. This randomized motion was once believed to be deterministic, but just that we didn't know which variables were affecting it. So It was indeterminate to us, but in reality, it was actually determinate. There were several experiments uh, which were performed, which at the very least refuted the locality of the variables determining the state of electrons or other quantum particles. Now, there is controversy surrounding those experiments, but the experiments do lower the probability of a deterministic model of universe being correct. We haven't seen any evidence that the indeterministic model or the non-deterministic model of the universe is false. In fact, there are several experiments that actually point to it. For example, the late choice quantum eraser experiment is actually a great experiment that shows that it is quite possible for our world to be in such a way that there is an influence of some things on the nature of the particles, which ideally should have had no effect. The only way those things can affect these quantum particles, if the quantum particles are in a state of confusion. Wait a minute, let me get something. Yeah, I'm back. So yeah, the part because the particles can be in the state of confusion, only then the knowledge could affect them. You could read about those experiments on any site or watch a video. Uh, but specifically, those experiments point out that it is very likely that two things are true. First, our own observation, or at least a type of observation, does affect the state of the particles. And secondly, the particles which we are talking about, a lot of gifts, must be in a state of confusion. Because if they are not in a state of confusion, if their position and velocity and momentum are already determined, then the observation should have had no effect on them. Because the observation, if any observation takes place, right, and even if it displaces the particle, we can know the original position of the particle by following through the equation. The only way that a significant change in the particle's status could occur was if the particle in question, I can heal it, I think. Yeah. So if the particle in the question was in some state of confusion about its own nature, to understand that more deeply, we'll uh, try to look at what the properties of the particles mean. So let's say that there is a particle, right? And the particle in question. Can I think I will be able to make. And the particle in question uh, it have these properties, right? Which are all attached to it, which is a specific type of mass, a specific type of a specific amount of velocity in a particular direction, amount of mass, and all of these properties are associated, let's say, with this particle. Now, just imagine that if we try to measure these properties of the particle, one of the arguments ever given hmm, in order to support Heisenberg's uncertainty principle was that we try to measure the properties of the particle, what we are using to measure these properties would affect the particles, because obviously to measure these particles we will have to interact with them. And the moment we interact with these particles, in a nutshell, what happens is that what happens is that the particle status changes. So, for example, a particle in a specific position may be bombarded by a beam of light or a ray of light in order for us to in order for the ray of light to be reflected back and tell us the position of the particle. But the ray of light would energize the particle, and the particle would not remain in the same position. But this itself does not show that the particle's properties must be in a state of confusion. What does show that the particle's properties must be in a state of confusion is to say that our own observation would affect the status of the particle. So the way we are measuring the particle would cause a change in the particle. In late choice quantum eraser experiment, you will read that when you measure the particle's position is enough to cause a change in the property of the another particle. This is quite surprising because it tells us about two things: that these particles are somehow linked and affecting one affects the another, which is called spooky action at a distance. And the second thing is that our observation of the phenomena these particles exhibit, the way we are taking in measurement, does have an impact on the particle in such a way that it changes uh, the properties of the particle. So our interaction with these particles is uh, just an interaction of knowledge. So, for example, when we look at the position of a particle, right, and we know the position of the particle, we are not affecting the particle in any other way except in a sense that we now know the property of the particle. How can the knowledge of a property of a particle change the property of the particle? The answer that is usually provided by people who believe in this interpretation of quantum mechanics is that whenever we have the knowledge of the I need water. So yeah, there's a thirst bar here which you need to replenish. To replenish it, you need to go to a water source, crouch, and with an empty hand click right, spam right here. Yeah. So one of the answers that is given by the people who believe in this interpretation of quantum mechanics is that, hey, nice dinosaur, is that uh, what is this? Is that whenever we have the knowledge of the particle's status gets defined. The confusion ends. Because particle achieves a deterministic state, it affects the state of the other particles, which must be related to this particle by a sort of a relation. That relation can be can be based on the idea that one of the particles may have a positive spin and the other particle has a negative spin, or any of the other associated properties. That is not important, however. What is important is that our knowledge does seem to have an effect on the property of the particle. And the only way determine an action of determination of a property could have an impact on the property is if either the property was determinate or it was indeterminate. But it cannot be determinate, because if it was determinate, then our act of determining the property would make the property indeterminate to us. But actually, when we are trying to determine the property, we could be successful in determining the property. So it must have moved from the state of non-determinism to a state of determinism. This is the insight that quantum mechanics gives us. I'm searching for. Yeah, let's get some together. So This is the point, right? When quantum mechanics tells us this, right? This is interesting in itself. A lot of things become understandable. For example, we come to know, for example, we now come to know how the world could have been started by merely an act of knowledge. And this does not require any sort of material reality or energy to be present in the first instant. By merely a mental exercise, could the world have been created? And thus, we solve the problem of the world seemingly coming from a void. Remember, thoughts and ideas also come from void, at least in a sense that we understand them to be philosophically. This is the reason why new knowledge is possible, because there is something that is added on when you are trying to use intellect into the nature of the particles, in the nature of the ideas. This extra information allows us to have knowledge. It allows us to know something which we didn't know before. But that knowledge comes from the void, in a sense that it is not based necessarily on the previous knowledge. But if it was necessarily based on the previous knowledge, then all the people in the world should have all the knowledge. There would be no any need for extra knowledge. The reason why there is a need for an extra knowledge is because all people do not have all the knowledge. And the reason why all people do not have all the knowledge is because knowledge itself is contingent on the fact that there's something extra that the human mind cannot grasp in its most pristine state. As such, it is an addition, but this addition has to come from somewhere. This addition obviously cannot come from other people when it is a new discovery or new invention. So it must come from, as the people have pointed out, void. So this new information then gets slapped on anything previously that we know about to give us new beliefs and ideas. This is how the process of acquiring knowledge works. After now we have known the process of acquiring knowledge, we'll have to talk a little more about how this knowledge affects the reality of the world. We already argued that this knowledge has an impact on the reality of the world, at least in a sense that it gives a state of determinacy to the properties possessed by the quantum particles. But it affects the world in other ways too. The other ways, what other these other ways are, would be discussed, I guess, uh, at some another time. Now let's focus on the cave malaria. So yeah, uh, I'm just roaming and wandering like an idiot. I don't think that I have all the particles. I should be actually making some stuff. So I do have these things. Uh, I need to create an armor first. For the creation of armor, I will need some leather. And for getting leather, I will need to kill some animals, I guess. Like I can make pickaxe and just oh, go and mine things. That was unfortunate. So it's very difficult to get life back in this game. Right? It is advisable to not mm, lose lives. No, I cannot get that back. I will try shifting. Yeah, actually shifting does a lot better because I don't have to point to the item to pick it up. So yeah, So this game is interesting, right? Because it creates the feeling of not knowing what Minecraft world is actually about. For those players who have played this for Minecraft, standard version of Minecraft for quite a long time, you can find several mods and make this whole no. Yeah, everything I lost thanks to my stupidity, and I'll have to gather all those resources again. Let's do things a little faster this time. Fire. Maybe I should do that off stream. Yeah, so let's end the video right here. I'll gather a few materials and then I will talk about quantum mechanics, more of it in another video. So yeah, bye I guess. See you next time.